All right, I just decided to end the video since it's already 16 minutes, so we'll just start it off here. So hopefully you guys did it. So now this is part 2 of it. All right, so find the probability that C is less than 2.02. So again, let's say 2.02 is roughly there. Now again, I want Z is less than that, so I'm showing all of this. Okay, which means, right, everything's to the left, so very good, right? That's all good. We're going to our portion. So first two numbers is 20, right? So remember, it's 2.0, the first two numbers. So do not just ignore the 0 because you want to. You have to put all the numbers. So the first number is 2.0. So you should be looking at here. And last number is a 2. So our answer should be 0.9783 as our answer. Okay. So that is our area, or the probability, 0.9783. Now, another thing that you guys want to notice, right, z-scores are markers. It really is a marker on the curve. So the answer is this, not this part, the marker, right? This just tells you what the marker is going to cut off itself. Okay. So pop quiz real quick. What is the area to the right of this z-score then? Right, so hopefully you guys get 0.0217, right? Because it's 1 minus this. So we'll be fact, right? You got to be worried about that. So you can always go forwards and backwards. So you'll see that in a little bit as well. Okay, it's actually the next one. So number 3. So find the probability of x being greater than 1.57. Okay. Right, so here's roughly 1.57. Here's our marker. But I want everything bigger than that, so that means I'm looking for this part now. So I want everything to the right of that value. Okay. So in other words, we're looking for that now. Well, unfortunately, the only way to get that portion is only get our z-score table only gives you area to the left, which means we cannot find that using our chart automatically, but to do one extra step. So first thing we have to do is find the area to the left of 1.57, because remember, the whole question now is we're looking for this number, not that anymore. Okay. So first off, what is the area to the left of 1.57? And that should give you 0.9418. 0.9418. Okay. Right, but again, that's not my answer. I wanted everything to the right of it. So therefore, I have to do what we did the last one, right? 1 minus that particular value. So 1 minus 0.9418 gives you 0.0582. And this is what we're looking for. That is my true answer there. Okay. Right, so last one is 4. So kind of cut off here, but it's not too bad. Okay. So we want z is greater than negative 0.23. So here's negative 0.23. And again, I want everything greater than that, so I'm showing everything to the right of it. Okay. But again, just like the last question, I cannot find it, right? I have to do the exact same process we did for this one. Okay? All right. So in that case, I got to find first a to the right of it, or sorry, to the left of it. So now here's the thing. It says, let's see if I can get it in here. Come on, focus. Okay, greater than that, right? So 0.2. So the first two numbers are 0.2. Notice that? Still first two numbers. So since it's negative, I go up here now to 0.2, which is right here. Negative 0.2 is my first two numbers. And the last number is a 3. So which means my number I'm looking for, the area should be right here, 0.4090. 4090. So therefore, this is 0.4090, All right. So, but again, that's not my final answer because I want everything to the right of it. So I just do 1 minus 0.4090, which gives you 0.5910 as your answer. Okay. Okay, all good there? Okay, so now let's go on to number 5. So number 5 is a pretty interesting one. Okay. Okay, so 5 says this, so it says between. Oh, and actually, real quick, just put these the other way. I kind of messed up here. Like that. I should go in the opposite direction for number 5. And then number 6 as well, but since we're number 5, this is the first one. And can you focus for me? Thank you. Okay. Right. So let's just look at what this means, right? So here's, let's say 0.23, and here's negative 1.33. So remember, what does this mean, right? I want a number that is greater than negative 1.33, so that's greater than. Also, the number has to be less than 0.23. What that means is you're shading the between stuff, right? Because only numbers between here satisfy both. That's a bigger than this, but also smaller than that. Not or, right? It's got to be between them for both of them itself. So any number between here works. So now we've got to find the area between these two z-scores, okay? Which is pretty interesting. So how in the world can we actually do this kind of stuff, right? Well, it's actually not as bad as you may think, okay? So let me rewrite what we have here. So we want the probability of negative 1.33 is less than z is less than 0.23. Okay. Now let's think about this logically. Okay. If I find the area to the left from here, that means I get everything what I want, except, right, correct? Everything what I want, and also this space over here. Everybody understand that? So again, if I find the Okay, if I find area to the left of this z-score, it gives me everything what I want, plus this part here, which I don't want, correct? Okay. Now the question is, how can I get just this part using from here all the way down there? Well, let's see, right? This is what I want. This is what I don't want, because then from here, it goes give me everything from here all the way down, including what I don't want. But notice, what I don't want is exactly the area to the left of this z-score. So essentially, if you guys remember the overlap stuff where we subtract, that's the same concept here, right? If I go from here to here, I have everything what I want and what I don't want. And if I subtract what I don't want, I get exactly here, the middle part. So essentially, when it comes to this overlap stuff, or this between probabilities we were actually looking for, okay, it's actually going to break it down to an equation. This is going to be the probability of z being less than, let me redo this, 0.23 minus the probability of z being less than negative 1.33. So we're going to find the area to the left of this one, area to the left of this one, and then subtract the both areas. Now, this does not mean subtract the z-scores. Notice I never said nothing about z-scores, right? This is complete areas. The z-scores are markers. You should never subtract z-scores to each other. We're always going to be subtracting the areas respectively of each one. Okay. So first, we got to find the area to the left of this z-score. And I was just looking at a table, right? So first two numbers are 0.2. Last number is a 3. So that's going to be 0.5901. And minus the area to the left of this z-score. So once again, just look at the table, negative 1.33. Should give you 0.09118. And then you finally subtract them to get your total area between the two z-scores. So our answer is going to be 0.4992. Okay, and that's how we do area between the z-scores. All right, so pretty tricky, right? But again, all you do is whenever subtract the z-scores, subtract the areas. And notice I didn't find area to the right of anything. It's area to the left of you subtracting. Okay, so let's do another example 6 down here. Okay, same process, just flip these around. It should be pointing the other direction there. Okay. Right. So example 6 says, again, right, we want the probability of the z's being between 1.1 and 2.23. Okay. Right. So I kind of messed up on my notes here, but you guys can kind of see. So this is 1.01, and this is 2.23. Again, you don't have to be as accurate when it comes to, just shading stuff, as long as you understand, when it comes to it. So things like that. So I want between these numbers. Okay. So we're going to follow the exact same process we did here. Okay. So therefore, since we want between, we want the probability of z being less than the bigger one, 2.23, minus the probability of the smaller one. So z being less than 1.01. So if you notice, it's always right minus left. It's easier to think of it that way. Okay. So find the area to the left of 2.23, which should be 0.9871, and a minus area to the left of 1.01, which should be 0.8438. Okay. And then finally, we subtract them to find the area between the two z-scores. So grand total of 0.1433 as your area. Okay. Now, again, right, when it comes to interpreting things like this, I'll give you guys this one here. So when it comes to interpretation, so we could say the probability, because we asked for probability, of the z-score is between, now what are they between by? 1.01 and 2.23 is 0.1433. That's how I interpret these numbers. Okay. And we'll talk about more, since we're just talking about z-scores, we'll say this, but usually we're going to talk about an actual equation and actual numbers, or the x value itself. But for now, that's a good interpretation of what this represents itself. Okay. Okay, so that's pretty much it. That's pretty much the section all about. So all it is just going over the areas underneath the curve and getting comfortable finding areas underneath the curve. And these are the three situations you're going to have is just area to the right, area to the left of it, which is the easiest one, just look at the table. Then you're going to find area to the right of things, so that portion there. And then finally, areas between them. Those are the three scenarios we're going to talk about when it comes to areas between the curves, or underneath the curve is to the left, to the right, and also between them. Okay. Now, last note for this one, last little note is, actually not a little note, it's kind of like notation itself. Okay. So notation. Pop quiz. A z-score gives the area to the what? Whole piece to the left, correct? So it's always area to the left. Now, when it comes to notation, it looks like this. Okay. It's z subscript alpha. So that's just a Greek letter. It says alpha. Okay. So alpha means alpha. Okay. Alpha. This is saying, actually, do I want to talk about this yet? Yes, I actually do. So what this is saying is the z-score that has area to the right of alpha. Okay. This is a quick little notation. We'll talk about this more in 6.2, but I just want to quickly introduce it now. Okay. It's just a quick notation. We'll talk about more in 6.2, but just in case you see it in your homework, you're going to see what that means. Okay. All right. That's it for this section. See you guys in 6.2.